Hi everyone, this is lesson 412, factoring with area models. Last lesson we introduced the idea of what factoring was. And just to remind you of that, I have some of the same notes from last time. So at this point you should know, one is what area model is and how we're using it to write area as a product and area as a sum. All right, so make sure, we're going to review this right now. So in case you weren't sure how to use it, definitely we're going to use that right now. But I just want to remind you of that. I also mentioned what factored form was, in case you missed that last time, and then what a factor is as well. So factored form would be area as a product, right? This is area as a product, is also known as factored form, and each of these would be considered a factor. All right, so that's our goal, is to kind of write things in factored form in this lesson. And so to kind of review that, I've started a problem for us where we're trying to write the area as a sum and as a product, keeping in mind that everything inside the area model, everything inside is considered our sum. So if I just add up all the terms inside, you'll notice these are the same terms that are inside, and I simplify them if I can. Negative 35 and negative 4 gives us a negative 39. This will give us our area as a sum. So that's one thing. The extra work that's going to come next is how do we get the area as a product? So you'll notice there is some information missing on the outside, and that's what's going to end up going over here, area as a product. And so our first step is to figure out what goes on the outside. And so we would look for some common factors. So what goes into 10 and 35? That's for us to figure out. If you're not sure, you could start with easier columns or maybe even focus on a row. So 35 and 14 or 10 and 4, right? There's no rules of where you need to begin. You could start with whichever one makes sense to you. And so let's say I'm going to start with, let's say 10 and 4. Well, 4 doesn't go into 10, but I know 2 does. So, and they both have an x. And if that's 2x, then 2 times what would give me 10x squared? And so that has to be a 5x. So then that must mean that 5 is the number that goes into 10 and 35. And then we're looking at 4 and 14. And so this would be a negative 2. Right, so since this is a negative, I'm going to pull out the negative as well. And that would make this other term negative 7. So negative 7 times negative 2 gives us a positive 14. All right, so make sure to double check these. Negative 7 times 5x gives you negative 35x. So if you do it too quickly, if you don't check, you might make some small mistakes. You might accidentally put a plus. That happens a lot. So keep a lookout for that. So that's pretty much it. So area as a product, we'll write this as 5x minus 2 and 2x minus 7. And that's us factoring. So we're going to look at this pretty much the same thing, except we're going to introduce some new terms onto the next problem. What we're really doing is factoring quadratic expressions. So we haven't been using this term before. We've been using area as a sum, area as a product. We've been focused on those terms, but the reality is you've been doing something a lot more complicated. And in this case, we call these quadratic expressions. So all these expressions we've been looking at kind of look like this: ax squared plus bx plus c, where there's usually like 3 terms you add together. It looks like the area as a sum. This is a quadratic expression, and it is one in standard form. So this is another form. We've talked about factored form. Now, this is to let you know this is what standard form looks like. This is also assuming the value of a does not equal to 0. So we don't want this to be a 0. It's going to be either a 1, 2, some other number. All right, so when we talk about factoring, what we're looking at is writing this expression from standard form into factored form. So when we write it as a, we're given the area as a sum, and we're going to write it as a product. That's what we're going to do here. So standard form to factored form. So, and we have a couple of tools. I've been talking about area model for a while in these notes. One thing I haven't talked about, and I'm kind of just getting ahead of ourselves, is there's another tool we've been using. In our book, it's actually called the diamond problem, or just diamond. In the homework we've been using Delta Math, and in there they call this the X game. That's one of the topics. So if you've been good at that, then this should be pretty easy for you. If you've been struggling with those, then you're going to need to make sure you put some extra attention to doing well on those, because that's going to help you on these. All right, so let's try this. Just jump right into it. Here's an expression that we are trying to factor. 2x squared plus 5x plus 3. I've kind of already set it up for us. This is pretty much what I would expect you to do. It is possible to factor these without drawing out an area model on X game, but these are tools and strategies that work for more complicated problems that are almost impossible to do in your head. All right, so what we're really just trying to practice is how to use these tools so we can handle any type of problem. And so try to get in the habit of just drawing these out. It's the simplest thing. You'll notice that in this area model, I've already filled in 2 terms. And you should notice those are the first and the last term of our expression, right? So that's pretty easy. Copy. So if you know how to copy terms, that's pretty easy. You'll also notice on the X game, I filled in one of them as well. Here's our 5x, right? So before even starting the problem, I just set it up, and it makes it a lot easier to kind of factor these expressions. Now, usually, like on the previous problem, if everything's filled in, it's a lot easier. We don't have to do this. So if we have the other 2 terms, then we can focus on the outside. So our goal is to figure out what these 2 terms are. Now, what I do know is these 2 together are supposed to add up to 5x. So that might seem easy for some, like, oh, that's so obvious. I know how to add 2 numbers to give me 5. Well, you're right. I could put 0 and 5, or I could put 1 and 4, or I could put 2 and 3, or I could put 6 and -1. I could put 7 and -2. This never ends, right? So I don't want to be guessing because there has to be only one correct value that goes there. And so that's where the X game comes in. So what I'm missing, though, is this number on top. And so there's a reason why I've highlighted this. I believe from another lesson we talked about a pattern that we noticed with the diagonals. And so in this case, we want to use that pattern. So if I take these 2x squared and multiply it times 3, that's what's going to go at the top. So this is going to be a 6x squared. So that's going to go there. All right, now that's set up. Now our goal is to figure out what are the 2 terms that complete this. So as a reminder, there's these multiplication and addition symbols here to remind you. So what 2 numbers can I multiply to give me 6x squared? And when I add them, they give me 5x. So this is your goal to kind of get better at this. So there's a positive 3x and a positive 2x. Right? If you choose different numbers, like if you said, oh, well, I know how to get 6x squared, these are the ones that I multiplied. Well, that doesn't really work because you can't add those two together. They're not like terms. So you'll notice that we can only add these, right? But the numbers are very similar. So in this case, our next step would be to just copy. I'm going to put plus 3x and plus 2x. Once you have those answers on the x game, now we've completed the area model. Now all we have to do is find the outside terms. So this would be an x, and this would be a 2x, and this would be a 1, and this would be a plus 3. All right, so I'm looking for common terms. So 3 goes into both of these, 2 goes into both of those, and then 1 goes into both of those. Same thing here, only x in common. So factored form. So, oops, that looks funny. So factored form is going to be x plus 1 times 2x plus 3. All right. And oops, that's pretty much it. All right, so that's what we're looking at trying to do. Setting up the area model next game and just start working on one term at a time until we've figured out what the outside terms are. If you try to find shortcuts to this, every once in a while there's going to be some faster way of doing it for sure, and we are going to look at those. But for the most part, what I've noticed is for those people that try not to do the X, they try to do only with the area model, they tend to get stuck on certain problems. So this might be one of those type of problems as well. So I've started it for us. I've drawn out the area model in X. I still left the diagonal highlighted just to remind you. But I'm going to work this one out from scratch. This one and another one, and then I'll give you a few more to practice on your own. All right. So you'll notice nothing's filled in this one. So I'm just going to start this by one is I'm going to identify the first and last just to remind me where they go. All right, so this is going to be 6x squared and a plus 12. And if I remember correctly from the last time, the middle term will go at the bottom here. So this is a positive 17x. All right, and then to get the top term, I need to multiply those two. So that's 6 times 12. What's 6 times 12? All right, so that's going to be a 72x squared. All right, definitely a large number there. And so we'll see how good we are with this one. All right, so where do we begin? We're looking at what two numbers, when we multiply them, they give us 72x squared, but when we add them, they give us 17x. So that one's definitely going to be a challenge. You're going to have to know what numbers can you multiply to give you 72. So if you don't know that off the top of your head, then you're going to have to start thinking about using a calculator to make this a little bit easier for you. So for sure, or if you can make a list. So 1 times 72 is an option, right? Or 2 times 36, that's another option. Or 3 times 12, does that work? 6. Oh no, 4 times. I think it was 4 times 36. Oops, 4 times 12. 48, 5 times 12. Oh man. 1 times 72, 2 times 36, And so this is be, 18. Half of 36 is 18. So that's 3, 4. 4 times 18. That's another option. Or 8 times 9. All right, you'll notice I'm making a list, but on the left side, the numbers are getting bigger, but on the right side, the numbers are getting smaller. I can't, 8, there's no other numbers besides 8 and 9. And so I'm noticing 8 times 9 is 72, but 8 plus 9 gives us 17. So that's perfect. So we'll use that one. So I'm going to put positive 9x and a positive 8x work for us. All right, so I'm just going to put those in, plus 9x, plus 8x, and then I can start filling in the outside. So this would be a 3x and a 2x, plus 4 and a plus 3. All right, so that means our factored form is 3x plus 4 times 2x plus 3. You'll notice I still put the x's first when I write these. I do not write it as 3 plus 2x. Right? Always try to make sure you put those x's first. All right, big numbers for sure, a little bit more challenging. Even threw me off for a second, but it's going to take more time if those numbers are a little bit more challenging. All right, so here's another one, another good one to have in our notes. 4x squared plus 17x minus 15. All right, so I'm going to plug in the numbers we have. 4x squared minus 15, and then I have a plus 17x at the bottom. All right, getting a little bit faster at these. 4x squared times negative 15 is going to give us a negative 60x squared. All right, you'll notice now we have a negative at the top. A little bit more challenging. So what two numbers can we multiply to give us a negative 60, but they give us positive 17 if we add them? So think about all the numbers to give us a negative 60. Sometimes we don't know which number is going to be negative. All right, since this is negative, one of these is going to have to be negative, and one of them is going to have to be positive. All right, so that's what I do know. So that means if I have a positive and a negative, this one most likely is going to be bigger than 17. So I could subtract a number to make it smaller. All right, so off the top of my head, I'm thinking 20 times 3. So 20x times 3x. 20 times 3 is 60. But I do need this to be negative. So one of these has to be negative. So since I do not want to have 20 negative, so be careful here. If you do 3 minus 20, that's going to give you a negative 17, which we do not want. We want a positive 17. So the order does matter here. So 20 minus 3 gives us 17. So that means this one, the 3 needs to be negative. So be careful there. So now that I know those, 20x, negative 3x, I'm just copying these terms and putting them in here. And then I can work on the outside. So this is common denominator in that column is 4x, which would make this one x. And negative 3 goes into negative 3 and 15, which then makes this other one at the top left positive 5. All right, so that means our factored form, or our answer, would be 4x minus 3 times x plus 5. All right. All right, so that's kind of an idea of how to do your factoring. Hopefully it gets a little bit easier. I put a list together of 3 problems worth trying on your own. And then if you need answers to these, let me know. And if you need me to go over these in class, I could do that. So, all right. That's it for this lesson. Next lesson, we will be practicing these a little bit more challenging ones as well.